Hi boys and girls, I hope you had a lovely weekend. So this lesson would fall on Monday, which is today, the 8th of June, if you have followed the work schedule accordingly. Right, so thus far we have identified the cases of congruency. We got into a little bit of discussion about what congruency is, and I showed you how to name triangles correctly. Now please remember, I will emphasize that it is essential to name the triangles correctly. Today's lesson is moving on to the actual proving. So we are going to go over proving triangles congruent and the format and how you actually represent your answer. Please, again, it is important to set out your work accordingly, and I'm going to show you the steps involved. So please, when you are asked to prove triangles, do it in the way that I'm showing you today. Okay, so question 1. Prove that triangle ABC is congruent to triangle DEF. Right, so you have two triangles here. I've started with a simple example with numerical values, and then we'll move to different levels of difficulty. Now the basics, again. So always remember, you start off with, so question 1. Now in maths, in geometry, there's a mnemonic or an abbreviation, RTP. And what does RTP mean? Required to prove. Now, some teachers don't use this anymore. In my days, which was not very long ago when I was in school, we were taught to write that down. Now you don't have to. But for those of you who would like to. Now, what does RTP mean? So I encourage you to divide your page so you can use the margin. And you can use the margin and you can put that in there. And then you have your statement and your reason in that section. I always like to have your work laid out. I encourage you to set your work out properly. Right, so RTP. What are you asked to prove? What are you required to prove? You are required to prove that triangle ABC is congruent to triangle DEF. So you're basically writing down the question. And then you put down this word, proof, which I would like you to do, because this is now all you're working out. When asked to prove triangles congruent, and I've told you this when we did geometry of lines and 2D shapes, get into the habit of naming the triangle or the shape you are working with. It gives us a clear understanding of what you are working with and the area with which you are working and where you are doing the calculations. But with proving congruency, you have to. So therefore, I encourage you to do it early on. So by the time you get to this point, you are familiar with naming the triangle you are working with. Okay, so you are obviously going to work with triangle ABC, and you are going to work with triangle DEF. So you say that in triangle ABC and in triangle DEF, this is what's happening. So remember, you need 3 things based on the 4 cases of congruency. So you need to list it. Sometimes you might not have it stated there. You've got to do a little bit of calculation. So find it first before you actually start with this. And if you've got to show how you got to the answer, do all the calculation first. Or you can do it on the side here. It's up to you. So you always say that's the format, 1, 2, and 3. You always need to find 3 things because all of the conditions involve 3 things. SSS, SAS, AAS, or RHS. So you wouldn't have more than 3 reasons or more than 3 sides or angles equal to prove congruency. Right. So let's write down. What do we have given? Now, because I mentioned triangle ABC first, I have to list all the angles and sides in triangle ABC first. Okay. So remember, it is essential to name correctly. In triangle ABC, I have angle B. I've spotted angle B, and angle B is equal to angle E. But that's my statement. Why am I saying that? Because it is given. It is given here. It's indicated on the diagram. So I didn't have to work it out. It is given. And that is your reason. We award marks for statement and reason. So please, this layout for congruency is important. Learn how to do it correctly. Second reason. You can see angle C is equal to angle F. In no particular order. If you want to start with that, it's fine. So you can actually say is equal to 35 because it's given. The second reason, as we said, I spoke about triangle ABC first, so I've got to name the angle in triangle ABC first. And in this case, it is angle C. Angle C is equal to angle F, and that is equal to 70 degrees, and that is given. Okay. And what's the third? There's a side. So AB is equal to DE, and that is equal to 35 centimeters. And my reason is given. Now I've got my three reasons. So that's AAS. So we've got AAS, which gives us the condition for congruency. And then after you write down your three reasons, you will say therefore. As you all know, those three dots written in that formation represents therefore. You've got to answer the question. Therefore, triangle ABC is congruent to triangle DEF. And you've got to state your reason for it being congruent. Now, in the previous lesson, all you did was identify the case of congruency. You worked it out mentally. You looked for the sides and the angles, but you didn't write it down. You weren't required to write it down. In today's lesson, you are now required to write it down in a formal proof. And this is how you would prove congruency. Now, question 2 is asking you, why is AC equal to DF? So, AC is equal to DF. Remember, proving congruency proves that the two triangles are identical. Now, by proving that triangle ABC is congruent to triangle DEF, we have now proved. So, that was question 1. Question 2. AC is equal to DF. Why? Because triangle ABC is congruent. Oops, there's the DEF. That's it. And what else would this prove? By these two triangles being congruent, you not only proved that AC is equal to DF, you also proved that angle A is now equal to angle D. And you've proved that line BC is equal to line EF. So that's what congruency proves. Later on, after a few lessons of basic proving, we will get to proving lines and angles equal by using congruency. Where I don't tell you to prove congruency first, you go straight into it. You've got to know you have to use congruency. So congruency helps you to prove, besides proving triangles congruent, it also proves that lines are equal. It helps you prove lines are equal, and corresponding lines and corresponding angles are equal. Okay, so this is example 1. Let's move on to example 2. I'm going to do 3 examples with you, showing you how to prove congruency and how to write down the notation. So let's do this one. I've chosen a circle one because it's quite a common one. Okay, let's just get the focus right here. Okay, so example 2. In the diagram below, B is the center of the circle. Important information. As I said when we did geometry at the start, always read the information. And if B is the center, that makes a big difference. You cannot assume that B is the center if it is not given. And B1 is equal to B2. So they gave us another bit of information that angle B1 is equal to angle B2. So firstly, let's mark that down. So B1 is equal to B2, and I've used highlighters to show you that. If B is the center of the circle, and if you've got a line drawn from the center of the circle to the circumference, what does that make it? That's the radius. So we know a radius, so AB is radius, and then we've got another line drawn from B to D, which means BD is also the radius. And does the radius of a center change? No. If you draw, it moves around here, it doesn't change. So we know that the radii, one radius, radii are equal, many radii. Okay, so remember that. When it comes to a circle, look out for this. Many learners forget to see this, and hence they are stuck when asked to prove congruency. So let's lay it out. Question A. Remember, I said to you, so you divide your page, there's your margin, and there's your working out, and there's your reason column. So required to prove. What are we asked to prove? We are asked to prove that triangle ABC is congruent to triangle DBC. Here we go. Now, let's find out proof. Okay. So remember, you start by naming the two triangles that you're working with. In triangle ABC and in triangle DBC, you're going to list it. One, get into the habit of writing this down in this way, and then you're going to have your therefore sign there. So what's the first thing? It was given B1. Now remember, even though there is information given, it must be useful to you, and it can only be useful to you if it applies to the different triangles. If B1 and B2 were in the same triangle, that serves no purpose. You can't use it. You might be able to use it to find other angles that are equal. So look out. It must be. So if we're talking about B1, B1 is in triangle ABC, and B2 is in the other triangle. So therefore, you can say B1, you can use B1 equals to B2 because it appears in both triangles. Now remember, I spoke about triangle ABC first. So which one of the two B1 falls in that triangle? So you mention B1 first. So angle B1 is equal to angle B2. We don't know what the numerical value is, but it was given. So your reason for saying they are equal is it was given. Okay? What's your second reason? If B is the center of the circle, and if we know that AB and BD are the radius, and we know that the radii are equal, so you can mark it down as being equal there, which makes it another reason. Agreed? So AB, I'm going to use AB first because I spoke about triangle ABC. Look out for the radius. So AB is equal to BD, and you say radii. It's understood. You don't have to say radii equal, radii. This part I just wrote down there to show you what I was referring to, but you just mark it on your diagram and it's there. So we've got an angle, we've got a side. So let's look at what we have. We've got that side, we've got that angle. We don't have any other angle. So which means we've got to use SAS. So the side that we use has to be on this side because B1 has to be included. Remember, side included angle side. And if you think about it, BC is shared. BC is the common line between the two triangles, and we can use that as equal. BC is equal to BC, which is common. So you can write it as BC equals to BC if you prefer, or you can say BC is common. If you write that, then you'll say common. Okay, both are accepted. Now therefore, triangle ABC is congruent to triangle DBC. Why? Side included angle side. Okay. Next question. If C1 is equal to 13, what will the size of C2 be? So let's do it over here. Remember, by proving triangle ABC is congruent to triangle DBC, we have now proved the remaining sides and angles equal. So we know, so this angle will be equal to that angle. And this angle will now be equal to that angle. And this side will therefore be equal to that side. That's what congruency has proved. So they are identical. So if I flip this over there, they will map onto each other. They'll fit onto each other exactly. Equal sides and equal angles. So to answer question B, C2 will be 13 degrees. Why? Because the triangles, you can just say triangles are congruent. Although they didn't ask you for it, but that's the reason. Okay, so something to remember when you see circles, do not forget about the radius of a circle. Okay, all these notes will be uploaded for you, so you don't have to write them down. I'll write them out neatly for you and I'll put them up for you. Okay, one more example and then you have an exercise to do for the rest of the lesson. Now this is a slightly more difficult example, okay? And I've chosen this to show you how angles can be common and not just sides. So the colored section is just showing you the overlap section is here, and that's just the ordinary diagram that you would get. In the diagram, AB is equal to AE, so it's marked here, AB is equal to AE, as you can see. It is also given that line BC is equal to EF. Prove that, and it's marked for you, so you don't have to mark it. Prove that triangle ACE, so this little triangle here, which is in red, is congruent to triangle AFB, which is that one. Okay, and as you can see, this little section is the overlap section. Now watch, be careful with this. These things can become tricky, and I'm going to just highlight for you in yellow so you can see. So we're going to work with this triangle here. The color wore off there, so you can't really see it, and I'm going to go, that's triangle CAE, ACE, and then there's triangle AFB. Okay. How would we prove that the triangles are congruent? So remember, first step, RTP, draw your lines, use your margin if you want to. What are we required to prove? We are required to prove that triangle ACE is congruent to triangle AFB. Now you write down your proof. Always name your triangle. So first line, before even starting, in triangle ACE and triangle AFB. Before you start with the working out and the proving and stating the reasons, name your two triangles. Make sure you have them in the correct order. In this case, you take it from the question. You're going to list 3 things. Always remember, you will have 3 things or 3 reasons, and you'll have your therefore there. Okay, so let's look at it. So let's go to what's given first. AB is equal to AE. So is AB part of a triangle? That's what you need to look at. AB is part of the base, it's one of the sides on that triangle. And AE is a side on that triangle. So it falls in the triangle, so we can use that. I've named ACE first, so I've got to name A. So ACE is that triangle, so I've got to say AE first. AE is equal to AB. It is given. Okay, please remember, because I spoke about ACE first, I'm talking about AE first. And if you look here, AE is equal to AB. Remember, naming triangles is quite important. Now, but you can't, when you're asked to prove, you can't just take it from there. You've got to tell us why. But you can use that as a checking process. Okay, now, if you look at it carefully, you've got a side. What else? That's all we have. We've got the side given that BC is equal to BF, but there's a problem there, class. BC doesn't form a complete side. It is part of a side of a triangle. So you cannot just say BC equals to EF as a reason, because BC and EF do not form part of the entire length of a triangle, of one of the sides. It's part of it. So you can use that to prove something else, but you can't use that in your actual reason. I hope you understand what I'm saying. But we'll get to that part just now. But what you can see here is this angle A. Angle A, you've got triangle ACE and you've got triangle AFB. Angle A is sitting there. It is a common angle. So like you had a common side. So you can say angle A is common to both sides, to both triangles. So it's a reason. So you've got a side, you've got an angle. So now you either look for another angle or you look for a side that makes that angle included. So please be careful. And there is no other angle. You cannot work with another angle. So you've got to look for another side. Now, how do I use BC and EF? Now I'm going to work here. So if you look at line AC, let's look at line AC. AC is a straight line. Agreed? So AC is a straight line, and AC is broken up into AB plus BC. Correct? So AC is equal to AB plus BC. Now AC is in that triangle. It's the whole length of one side of the triangle. BC isn't. So you've got to focus on AC instead of focusing on BC. Now let's look at this triangle, AFB. Again, AF is the line. So let's look at AF. AF is equal to AE plus EF. EF is not the complete length of that side. It's part of it. But AF is made up of AE and EF. Now, so I've got to use AC and AF because they are the two sides in the triangle. So can I say they are equal? Yes, because AB is equal to AE and BC is equal to EF. So therefore, okay, it was given. So your third reason would be AC is equal to AF. And that's your reason. If they're all equal, so you can say that because AB is equal to AE and BC is equal to EF. So we're going to just move that down there. Or you could put this section there. It doesn't matter. So all of this is explaining why AF is equal to AC. So you've got your side, you've got your angle, and you've got your side. And that angle is included. Okay, so it's therefore triangle ACE is congruent to triangle AFB, side, angle, side. Okay, so please look out for tricky questions like this. You've got to form your triangle, and if you use that in a reason here, when you're listing the 3 reasons for it to be congruent, it has to form part of the entire triangle and not part of it. Right, grade 9s, please refer to the work schedule for the exercise that you are required to do. Have a good afternoon. Bye.